Let's find the limit as x approaches 0 from the right of tangent 2x raised to the x power. For this one, if I have a function, I can also rewrite it as e to the natural log of that function. So I'm going to do that, and I'm going to take advantage of the power rule of logs. So I can bring down the exponent. So it'd be e to the x natural log of tangent 2x. And here I'm going to use the exponential rule, which says that I can instead take the limit of the exponent. And now I'm just going to rewrite this in terms of sines and cosines. So we know that tangent is sine over cosine. So here it'll be sine 2x over cosine 2x. And sine of 2x, I'm going to multiply by 2x and divide by 2x. I'm allowed to do that because they cancel and we get the same thing. Okay, now this is going to go to 1. The reason is because I can rewrite this as, well, if I let u equal 2x, then as x approaches 0, u will also approach 0. So the limit as u approaches 0, sine u over u, which we know that's just 1. And so we can simplify this further. We have x times natural log of 2x over cosine 2x. And now we're going to use the power reducing formula. So we know that sine squared of x is 1 minus cosine 2x over 2. So we're going to use that. So if I solve for cosine 2x, that's 2 sine squared minus, or 1 minus 2 sine squared is cosine 2x, which that's what we have here. And actually, yeah, let's just write that, 1 minus 2 sine squared. I'm going to factor out a negative. So let's say I put a negative in front, so I'm going to multiply the bottom by negative to cancel that out and get 2 sine squared minus 1. So think of this as multiplying the bottom by negative to get to this, and then also multiplying the top by negative. So those two will cancel and you're left with the same thing. And now we're going to do something similar to what we did up here. I'm going to multiply this by 2x squared, and then we have sine of x over x squared minus 1. So that is equivalent. So basically the x squareds are going to cancel. So it's the same thing. And obviously we know that this is also going to 1, similar to what we set up there. So if e limit as x approaches 0 from the right, x times natural log of negative, and then you have 2x over 2x squared minus 1. So now we can use the quotient rule for logs. Basically, we're going to subtract this. So think of x as outside. We have natural log of really, it's going to be negative 2x minus natural log of 2x squared minus 1. but I can just write this as x times natural log of 2 minus natural log of x minus natural log of 2x squared minus 1. And so to solve this, I'm going to make a substitution and let x equal 1 over t, which if I flip both sides, t is going to equal 1 over x. And so as x approaches 0 from the right, t will approach 1 over 0, which is a positive infinity. So then we have e limit as now t approaches infinity. And that's going to be, let's see, x is just 1 over t, so that's going to be on the bottom. And then we have natural log of 2 minus, instead of x, we have 1 over t. And then we have 2 over t squared minus 1. Now, if we let t approach infinity, we end up with, on the top, it's going to be, well, ln of 2 minus 0, and then minus infinity over infinity. So that's going to be negative infinity over infinity. Use L'Hopital's rule. Well, the derivative at the bottom is just 1, so we don't care about that. And then we'll let's see, take the derivative, and so we end up with well, let's see, take the derivative of natural log 2, that's 0. Derivative negative ln of 1 over t. So negative ln of 1 over t is the same thing as negative ln of 1 minus ln of t, which is just negative ln of t. So we take the derivative of that, that's just negative 1 over t. And then take the derivative of the other one. That's going to be positive. It's 4 over 2t over t squared. 2 over t squared minus 1 times t cubed. And as t approaches 0, infinity. This is right. We said it approaches infinity. So this is going to go to 0. This also goes to 0. This whole thing is going to infinity. So 4 over infinity, that whole thing is going to go to 0. 0 plus 0 is 0. So we have e to the 0, which is equal to 1. And so our limit is going to be 1.